What is up, guys? Welcome back, another video. We just finished doing the Mercedes timing chain and pretty much everything we could do before we got to the timing link needing to crimp it. So all that's done, and as I was saying, video on this guy. So this is the Eaton M65 Supercharger, just a little guy, but does its job for that little 1.8. So what we're going to do is port and polish it. I want to get a bit more power through this, so I won't be changing the pulley, I won't be making more boost from this itself, but I want to turbocharge the car and retain the supercharger. Now the problem with that is this bad boy likes to generate a lot of heat. It's not so good for intake air temps and all of that, so you kind of want to reduce as much friction as possible in this unit. Increase the airflow, more the airflow potential, not so much the airflow from the supercharger itself. And yeah, we just want to kind of improve everything. So you can see here on the inside, huge lip around this whole face here. It's real coarse, it's not exactly smooth. Geez, I'm going to say that the mouth of this is probably pretty coarse as well on the inside, the intake mouth hair. This is the bypass valve, electronic bypass valve, so when there's too much boost or when you're cruising, idling, things like that, this valve is open, and instead of the boost being pushed through to the intake, it is reverted back in, and that is essentially the bypass, yeah, like blow-off valve, bypass, whatever you want to call it. And what I'll be doing is providing positive pressure via the turbo to this intake, so even when this guy decides he doesn't want to, or the stock ECU decides it doesn't want any more boost, gonna get more boost. You're just gonna cram it in there. Yeah, so first up, let's disassemble it. I gotta get this crank off somehow. I have a pulley puller thing that I'm gonna try, and hopefully that gets it off. If not, maybe a bit of heat. Heat usually sorts everything. And then we're gonna go through disassembly, pull it apart, see how we can improve it. So we'll be removing that entire section, which mates pretty much the same to this here. We're going to get rid of these corners, so they'll come into this and taper in a lot nicer there. And on this, we're going to taper all the way up to this edge. We are going to taper all of that in the side. There's quite a lot of material here. So this edge up, we're going to remove this edge, roll it in that way. Obviously the seam here has to go, that's nasty. Seam here not as bad because that's I'm not too worried about what's going this way. We might clean up some of these casting marks here. That's the bypass route, so not too bothered with that stuff. We're going to taper all of this out too. Whole edge needs to go. Nice, smooth taper. So basically that whole inlet side, save a bit of time. Looks like we've got plenty of meat both sides, it's good. It's not really too much else I'll do there. And that feeds into this guy. So it's on 90 degree. Not so bad actually. Like if you look inside, it's actually got right there, there's a bit of a polishing that someone's done already. I likely say that's from factory just because it is the 90. And then I think with should be able to get it carbide, tapered bit, should be able to open up this orifice here, spread that out a bit. With these, I'm not too worried, they're not really going anywhere or doing anything, so I'm just going to leave that nice and simple, and that should increase the airflow quite substantially anyway. Gets rid of this, and then something I can't mark, but something I need to do. I need to surface the base of this. Need to clean that up somehow. Really going to be able to do much with that either, which kind of sucks. That's the roughest surface. I mean, honestly, the only real way to get in there would be cutting. Honestly, the real only way of getting in there would be cutting this with a bandsaw, welding it back together, but no thank you. It's a doozy. This kind of gets in there a bit. But the potential for marking the inner barrel here with the actual Dremel itself, with the die grinder actually marking this, is quite high, so I'm not exactly comfortable with that. I might just get in there and clean it up. Might even see if I can just hand sand some of it at least. Yeah, I might be able to get a bit of sandpaper in there and clean it up a little bit. Nothing too crazy. Seen on a lot of other superchargers, that section's actually a lot more accessible. Not so much with this one, which is alright. Another area that we can improve, so that's pretty thick, is this section leading into the supercharger. It's a big step. There's another step here, lots of meat. So we'll clean that up, take that out, leave sides of that. Might be able to get, maybe not that. Ideally actually, so this sits side on. So that sits like that in the car. Ideally, I'm going to go hunt down a, whatever this diameter is, a hard turn to a 3-inch. To a 3-inch would be ideal. Do happen to have some chew, a little bit smaller diameter. So might just stick to the silicone idea. Anyway, battery's dying. I'm going to turn that off, get this set up, and we're going to go from there. Okay, so ported, polished, all that stuff's done. We got quite the big V sorted out here, nice and smooth. I managed to get the Dremel in there, carbide bit, and cleaned up that quite considerably compared to what it was, but I can't really do too much more simply because I don't want to start damaging the faces of this. Really getting pretty close, but that's a lot smoother. It's a lot better than what it was. I might get in there and just try and hand sand it with some heavier grit sandpaper and move up through maybe like a 180 or something up. I don't know. Anyway, I just tried to get some heat into this to tack in some aluminium plates, to chuck some plates in here, fill that, and for the life of me I can't seem to get this cast crap to weld. Well, I could if I started to put a ton of heat into it, but given how thin this is, I don't want to get too much heat in there and warp it. I don't want to like get this drooping, and I don't want to put any inconsistencies in there. So what I'm going to use is the Pimatic steel weld, Pimatic steel weld. So there's a few people that have used this with some good success. I've heard no horror stories. There have been skeptical people, as there are online all the time, saying that might happen, this might happen, and yet they drive a Camry with no mods or anything at all. So I'm going to give it a shot. I'm going to knead this up, chuck it in there, fill it in, and then we're going to get some fine, maybe 600 sandpaper on the other side just to make sure none of it's drooped. I have gone through and pushed my finger up, like press this tape up so it's kind of protruding into these gaps. These are silent supports. They actually bleed off boost, and they make it a lot quieter, and yeah, bleeding off boost, that's not what we want. So yeah, let's mix up some of this stuff and shmoo it in there. Beautiful. So that's all done. Probably gonna leave it overnight before I touch it again. I need to get back in there. Oh crap, I got some on the edge there. Scrape it off. So Eaton specifically says not to use JB Weld. This stuff's perfectly fine for it. Not to use JB Weld because it's not really structural enough. Doesn't have the tensile strength when cured to hold up. And there's an article where they state these will increase, or blocking these increase the efficiency of the supercharger with porting. And yeah, pretty straightforward. I mean, I wouldn't do this by itself. I wouldn't just open this up and just do this. That's probably a waste of your time. And it's a lot of work, and pulling this whole thing off just to fill in a couple of holes. Porting and polishing, that's probably where it's all at. Yeah, so I'm going to leave that overnight, and I'll get back into this in the morning, really gut this. I think a lot of efficiency is in this piece right here. I'll be able to kind of like bow melt it, taper these edges and get a good flow straight in, like so. And I'm thinking maybe I might have a look online tonight and see what people are using in regards to like a base setting for cast aluminium. I've welded casts before, like I've done rocker covers and stuff. There's one there I done the other day and that was fine. Like it's still dirty, but it was fine. I just can't seem to get a puddle started within a reasonable amount of time. And given that this is machined for these, like it's a very tight tolerance fit, I don't want to warp it. I don't want to get too much heat in there, but what I'm thinking is if I can find a good setting, I might try it on a different spot, grind pack somewhere where you won't see, not on the housing itself, and see if I can maybe just make a alley flat plate, like a straight edge or angled edge, put that on top, and if I can get enough heat to just slap a couple of tacks, maybe one this end, one that end, and have a tack sitting on there, it's a little bit more insurance, that'd make me a little bit more happier. But if I can't, send it, is what it is. And yeah, that's gonna call it for the day, boys. Do some more cleaning and stuff tomorrow, but the heat has taken it out of me. I'm done. Like, whew. But engine is coming together quite nicely. The timing and all that stuff is done, so yeah, looking good. Finish up tomorrow. Beautiful. So she's done. Now I've actually been calling it an M45, but this is actually the M65 Supercharger. A little bit different, basically the same thing, different size pulley. Yeah, done. That's it. You can't even really tell that it is ported and polished. Unless you get like the whole intake and stuff off, and you take it all apart again. And yeah. So I just heated up the pulley and gave it a whack with a hammer, and then I got a bigger hammer and gave it a bigger whack. And that seems like it's on there pretty good. It's not oil in there at the moment, but she's spinning pretty free. And yeah, pretty stoked with that. So probably gonna call it for this video. Basics of porting and polishing a M65 Supercharger. Very, very straightforward. Just smoothed it all out. Maybe, I think I went up to like 200 and 240 grit on the sanding wheels. Nothing too fancy, doesn't need to be perfect. Well, I didn't need it to be perfect for my application anyway. Yeah, just go ham. And that's, is it done? Can't even bloody tell. But you'll tell when it's on the car, making all the whiny boy noises, and yeah, should be good. I'm now just gonna measure this before I put it on the car, and measure this before I put it on the car and take some notes. I need to order some intercooler piping tomorrow. Get a big old Canyon filter, probably like the length of this thing, because the intake comes out, moves up, and then needs to sit above it. Don't really have space in front or in front of the radiator or anything, so for now I'm probably just going to get an elongated conical K&N pod filter and just slap it right on top, maybe get some ducting to it, but probably not, and call it quits from there. That's it. Yeah, so thank you for watching. Like, comment, subscribe. If you want any more information on doing a particular process, just chuck me an email or jump in the comments, have a yarn. And yeah, next video, we're gonna have it on whole serpentine belt, pretty much everything back on. Still waiting on the riveter for the actual cam belt, or timing chain I should say. And yeah, have a good one.